Hey people, welcome to Mech Digest by Komal. Today we are going to start with the modeling of radial engine parts. But before that, let us understand what the radial engine is. Guys, there's a type of internal combustion engine used mainly in small airplanes in which the cylinders are mounted in a circle around the crankshaft in the banks of two or more, and that is nothing but a radial engine. Today I bring for you the simple and easy steps to model all the parts of radial engine. Let us consider the first part as master rod. Okay. Considering the top view of the part, we are going to start with this area. The dimension of the circle is 63. Okay. So as we see that diameter 10 circles are at 5 places. Okay, but actually they are at 4 places. It is mentioned here 5 places. Make them equal. This is 15. This is 40. Okay. Now the vertical distance is 26 and 17. This is 26. This is 17. Now let us mirror them. Take the center line. Okay. Now we need to generate these arcs over the circles, and the radius is 13. Make them equal and dimension them 13. Okay. Now take 3-point arc. Let us make them tangent. They are 72. So first of all, make them equal. Now take a line which is 26. make it symmetric about the horizontal axis, and again considering 3-point arc. Tangent equal and equal to this one. Sorry. Let us first give the distance, which is 87 . Yes. So we are complete with this area. Okay. Now this will be extruded 28 plus 7 plus 7. Okay. So extrude. You can directly make the calculation here. Let us make it mid plane. Okay. Now the inside circle is diameter 52. Okay. And this would be extruded 70. Mid plane. Okay. So here we see that these are two plates of 7 mm. Okay. We have to remove material. So now let us project the outer edges and the outside circular edge. So we are going to consider an arc making them tangent here and here as well. Same for this one. Okay. And let us trim this line in order to make this a complete closed loop. Okay. Come to extruded cut. Okay, we need to make one edit in the sketch, and that is we still need to trim one more sketch. Okay, so now this is a complete closed loop. Extruded cut. Okay, now this cut is going to be 28 mm. 28 mid plane. So this is going to be the plate which we are able to see in this drawing here. Okay. Now considering the other side, we have a cylinder over here, 35 and 24. 24. Okay. To make it constrain, let us take both the centers and align them horizontal. Align them horizontally. Okay. The center to center distance given is 250. Okay. And it is going to be extruded 42 mm. Okay. Now for the middle part, we see that we have a taper edge in top view as well as in the front view as well. Okay. So take a top plane, project them, take a tapered line. Add an arc as we have to provide a fillet here which is R35. Make them tangent. Make them equal. Okay. We need a center line. Because we have to make it symmetric. But before that, we are going to trim the unnecessary sketch. Okay. Now make them symmetric. Dimension it 35 and the distance here is 18. Okay. Exit. This is going to be extruded up to 18 mm. And mid plane. Now we need to taper it. So in order to taper it, we need a neutral plane at this location. And to add a neutral plane here, let us take a point at the center of the cylinder and let us take a reference plane parallel to right plane on this point. So the first reference is right plane and the second reference is the point which we have defined. Okay. Now draft, define the neutral plane, define the faces to draft and the draft angle which is 2 degrees. Okay. So we get a taper profile here as well. Now adding the fillet of R78. on both the internal edges, upside and downside. Okay. Now we see that there is a elongated slot, okay, which leaves a plate of 5 mm at the middle, and above and below to that the material is removed. So we are going to consider this face. Okay. So the straight elongated slot is here. Okay. So the radius is 6 and center to center distance is 150. This is 150. Okay. Okay, and this distance is 30. So we have to drag it and make it 30. Okay. Now let us calculate the cutting depth of this slot. So the total is 42, okay, and the half of this is going to be 21. So we have to reduce 2.5 from 21, which makes it 18.5. So the depth is going to be 18.5. Let's mirror this feature with respect to the top plane. Okay. And in order to verify, we can measure the thickness of this plate. Okay, and this is 5 mm. Okay. So we are complete with master rod. Now let us consider the second part, articulated rod. Okay. So set up a new file for articulated rod. Okay, this is very simple. Let us consider top plane. Okay, here what we are going to do is we will try to make all the sketch in one and extrude it step by step. There is a shortcut method in extrude. So this is 15 and 24. 24 and 15. Okay. And this is 24 and 35. Let us align them horizontally. Okay, and the distance between them is 178. Okay. Take a center line. Connect them with 3 point. arc. Make them tangent. Here as well. Make these two lines symmetric. Okay, and the arc is 24 at all the 4 locations, so make them equal. Okay, and this is 18. Okay. Now we are going to extrude the regions one by one. Okay, so for that select the whole sketch, go to extrude, and here in selected contours define a particular region. So this is 28 mid-plane. Okay, now again make the whole sketch visible. This is 42. So select the sketch, extrude, define the region, and this one is 42 mid-plane. Okay. Okay, the sketch is visible. Select it, and now select both of them because they are divided by center line. This is 18. Mid-plane. Okay. We could also make the center slot in the previous sketch itself, but it's okay, we are going to make it separately. Using the same axis reference. (130) is the center to center distance and 10 is the gap. So this is 130, that's 10. Let us assume this 20. Okay. Okay, now the plate is 5 and this is 18. So this is going to be 9 minus 2.5. This is 6.5 and mirror the feature with respect to top plane. Okay. We can again evaluate to check. It should be 5, and yes, it is 5. You can hide the sketch once it is done. Okay. Let us save it. Articulated rod master rod. Okay. Now we are done with these two parts. Now the next part is going to be piston. On the right side view of the piston, we are able to see the sectional view. So let us start with the right plane. Take a center line. Okay. Let's take a 3-point arc and dimension it 189. Okay. Now we see that there are 4 grooves here. Okay. So we have taken the 4 grooves. Let us make these lines collinear, and same for these lines as well. Okay. So the groove gap is 3 and the outside line is 2. This is 3, this is 2, and this is 4. Let us make these lines equal. Make equal. Okay. Let us coincide. Okay. Now we have one more groove here. Okay. So this groove is 2. And this line is 7 from the bottom. But the horizontal line is equal to this. Okay. Let us make this collinear. Fine. Okay. Now the distance of this outside line till center line is going to be half of 85 plus 4 plus 4. So the total is 93 and half of 93 is going to be 46.5. Okay. And this distance is half of 74. Okay. Now the length of this line is given 62. And 45 is given from the last groove till the bottom line. So let us assume that this length is somewhere about 10. So our sketch is fully constrained. Now this will be revolved. Yes. Okay. Okay, now we see an elliptical cut here. Let us create that. Let us take a tangent plane and the perpendicular reference as right plane. Sketch. Okay. So the diameter is 39. There are some dimensional errors here, so we have made this assumption. So this will be extruded cut up to 4 mm. Why up to 4 mm? Because we see that the elliptical portion is tangent to this line and the gap is given as 4. Now let us do the inside part. Let's take a front plane. Okay. Making it up to next and giving it offset of 25 on the reverse side. Now taking this hole of diameter 22. Extruded cut, removing the material up to the next face. Okay. Now let us mirror these three features on the opposite side as well. But this would be mirrored with respect to the front plane. Okay. So we are done with the piston. Let us move to the other part, which is rod push upper. Before that, let us save piston. Okay. So ID is 22 and OD is 24. Twenty-two, 24, and the extrude length is 42. 42 mid plane. Okay, this is rod push upper. Now next is rod push lower. They are 12 and 15. And the length is 24. Mid plane. Next is piston pin. Which is 22 and 11, and the length is 80. Okay. Piston pin plug. So let's take a center line. Okay, so make it tangent. So this is 11 means 5.5. Then 22 means 11. Okay, this is R2. 3 and 12. Okay, let's revolve it. Still can plug. Okay. Master rod bearing. That's 46 and 52. It will be extruded to 70. The plane. Okay, next is link pin. Take a center line. Seven, 50. Ten and 15. It means 5 and 7.5. Okay. Link pin. Now last one is piston ring. R43, R47. T3 into 2. 47 into 2. Okay. This is 3. Okay, we see that there is a cut of 1 mm at 135 degrees. So it is very simple. we'll consider the right plane. Okay. This is 1. And 35. So extrude, cut it up to next. Okay. Piston rig. So we are done with all the parts of radial engine assembly. Stay tuned in with me, subscribe to my channel. In the next video, we are going to see how all the other parts of radial engine assembly are going to be assembled. Thank you guys.